Hello everyone. So this session is meant for understanding what is named pipe and how exactly one can achieve that through a program. So named pipe, that is FIFO, is an IPC mechanism that allows two independent processes to communicate using a file-like object. Unlike unnamed pipes, it has a name in the file system. Processes don't need to be related. That is, it is not necessary that they should be the parent-child processes. So core idea using this program, like what we are going to have a parent, which would be speaker, right, and child, which would be listener, and named pipe would be there, which is message channel. For example, I would be creating a message channel here with some particular name. Fine. So let me start typing the code, and then we'll work out. Named pipe online. Let's see. Now here, what I'm going to do is I'm going to create a named pipe. So this would be kind of like a program where I'm going to make use of function. I will let you know what the function is. Fine. So let us first include header files. Hash include std.h, uh, hash include unistd.h. Correct. Then hash include stdlib.h. Now I am going to make use of a few functions related to or few constants related to other all aspects. So that's why I'm going to make aspects related to files. Right. So that's why file control header file I will be using including here fcntl dot h. Then we are going to make use of fork. That's why sys slash types dot h. Then stat dot h. Okay, so we had stdio, stdlib, unistd, fcntl, sys types, and sysstats. Yes. Now let us define the common platform for communication. So let me define here a FIFO name. And the name I am giving to it is CA552. Let me declare a file descriptor and let me write the message that I want to pass. So buffer to hold the size as 100. Then let me write main program. This would be a parent-child relationship. Correct, here that I'm going to make use of. Okay, child process would be reader, parent process would be writer. Correct. So this is a sample case that I'm introducing here. Correct. So like these are going to be independent processes, not necessary that they should be parent-child, but in this case I'm considering it as parent-child one. Correct. I will exactly let you know what I'm writing at each place. Right. So let let us continue. So I would be using a function called mkfifo. We'll save this. Yeah. So let me show you what that mkfifo is. Man free. Mkfifo is a function which is used to create a named pipe, make a named pipe. Specifically, it is a special file. So that's what I'm going to make use of here. mkfifo. Then I will give name as FIFO name and the permission. So 0666 read write permission. So this will create a named pipe. Now what I'm doing is I'm creating a child. So if fork is equal to 0, then this would be a child process code. I want what? I want to open that FIFO, open the FIFO name and because this child process would be a reader for me. That's why I will be RD only. Now, if you don't include fcntl.h, ultimately you will be getting an error only. So O underscore RD only. So this is your open FIFO for reading. So let us read. Read. Now it is FD that we are going to make use of. Then the buffer where you would be reading that data into and size of. So read call is done. Now let us print what as a child you exactly saw there. So child process RECI received %s then buffer. Fine. Now once you are done, you have to close the file descriptor, saying that your work is done. Now else, now this will be parent process. Parent process will be a writer process. So again, so I will write FD, and instead of read, we are going to write it. Now in this case, it would be read only. Okay. So by open that FIFO, now instead of read, we will write. Now this write would be on the file descriptor, we'll write something. So let me say I am putting a message, and that message I am writing here. Message, correct. And this message we'll write with the data. Hello from parent. Fine. And then we'll write here explanatory mark. Now if you see, let us count character 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we'll write here the message. So message is message, what we wrote there. Yeah, capital M. Message. Okay. And then size of. So we are done with this. Now we are going to anyway write there. So close. Close FD. Correct. Then wait null, because we want that process to wait for a while. Yeah, I'm adding this slip so as to see, and we want to delete. So that's why I'm using unlink system call to delete or remove. So right, and then this would be used for removing the FIFO. Return 0 bracket. Let us see, and if we can find out some errors, we'll try to concentrate that and correct it. ls dash ltr. So p dash m32 named pipe online dot c. We'll correct the errors. Right. So we are done with this. So our code is done. Correct. Let us compile. So, okay. This types wait.h we have to include. Right. sys/wait.h. So let us execute this. On parent. Now, like what we'll do is we'll try to check whether the FIFO is generated or not. Right. So hello from parent is displayed by the child. Right. So let us see what exactly parent wrote. Parent wrote hello from child. Right. But and child process received this. So as per our code, if we see what we did here is in the parent process, we are writing just the message. We are not typing any message. So here one can say def parent process writing on a FIFO. So that like it can let us know that it is in parent process. Let us execute. So here, if we take another terminal, you can definitely check from here. So we'll write first this. Let us see what we have towards bottom. So there is just a dot out, right? So let me execute this. And if I fire this, you will see this pipe is generated. Now, once the writing is done over here, you must have seen writing is done. Program came out. So when we write this ls-ltr, you will see that is deleted. Now, once the pipe is created, you will identify that this P is added there, correct? To let you know that it is a pipe, named pipe created, right? So this is how the code works. So the function that we used here, like fork, correct? Then we created a FIFO using mkfifo. And as usual, we used write and so on. So named pipe, like key concepts here are, this is a file-based communication. Name pipe behaves like a file. It makes use of open, read, write system calls. And blocking nature would be like open read only and open write only. Correct. So waits for writer and waits for reader respectively, and which is used for ensuring synchronization automatically. So this example is unidirectional. Now for two-way, we can use two FIFOs. Correct. Uh, we will see in the next session where two FIFOs are used. Right? So named pipe, let us conclude this. So named pipe is a file-based IPC mechanism that allows unrelated processes to communicate using a persistent FIFO channel, which we created here. So this explanation is directly based on what the code I actually showed you or created in front of you. Thank you very much.